Yo guys, today we're doing something out of the ordinary. So usually I'm in like VR in Animal Company, or I'm flying drones or something. But in the background you'll have probably seen my 3D printer. And recently I've just watched Gibby VR. I'm going to get copyright struck, don't worry. And I realized that I can make things in-game real. So today, unlike beans, we're going to be making the arm, the robot arm. And it'll be my first ever thing posted on Bamboo Lab. But let's hop into Tinkercad. Wow, my spelling's so good. Then right here, recently I've been working on 3D modeling the tadpole and their stands. Hope you find these interesting. I do. Tinker this. This is very much blank. Why is nothing in here? What? Okay, so let's get to it. So let's see. The arm is similar to a lot of ball and socket joints. And a lot. Yeah. So, should be like the Dummy 13 arm. Let's get a reference image up on my second monitor. So, Animal Company robot arm. Yeah. Oh, this is good. Yeah. Looks like someone already did it though, but whatever. Well, put it on my second monitor, and we will go off this. So let's see. Recently, one of my YouTube shorts, I showed that if you go to Steam, loading, Steam. Okay, let's go off my reference image. So let's see. I'm gonna start off with the arm. Okay, so the joint appears to be like a cylinder, right? So we're gonna put a cylinder down in the center. Uh-huh. And then it looks like it's actually offset, so we're gonna split this into two. What's your height? Take you down to 10. Yeah. Control C, V, bring you up by 11. Then align. If you can't tell, this video is very boring. Oh, that looks good. Now here's the problem. How are we going to get it to move? Okay, wait, I have an idea. And people might not like this. Okay, so we're going to pull you aside after we just aligned you beautifully. And we're going to get another cylinder, but you see, it's only going to be 10, but we're going to shrink it to be 10 by 10. Yep, it's around half the mass. And these two right here, we're going to align them. I'm sucking very badly right now. It's the middle of the night. Okay. As you can see, it fits beautifully. But as you can see, if we did this, our current arm, for the forearm or the back arm, would just fall straight through if we just cut through a hole. So, I'm actually going to make this 9 in height. So that way we have a thin streak. And then we're going to duplicate this hole, move it to the side with you, and add a line. Alright. Now if we union group you should have a clean socket to put that in. And I just messed the whole beautiful thing up. So union group you. And ta-da! But as you can see, if we did this, it'd be airtight and everything would crack and shatter. So under union group, we're going to actually make the hole go up by 0.5. So that way to loosen enough it'll move, but it's tight enough it won't fall out. No, 2.5 is that. I don't know what I'm saying anymore. These probably is cut out. trying to think of how I want to do the arm. Because it like grows at the end and then shrinks at the middle. So this only allows me to show its sides. But if we just do you like that, and do you like this, it should be perfectly flat. But let's hold that off. Stretch it to around. Let's give it 60. Just like that. We have a good looking arm. I'm going to save this for later. And it looks like we have to flatten it a bit. So I'm going to scoot it down. Now, right here comes the fun part. A line like this. Bring it up. Scooch it closer. So we do not have anything that could greatly represent the type of sphere in-game. So instead, we'll just be using regular ball. Oh wait, we lower it down like this. We actually get around the game size, or game-like. So let's increase it. Let me... Alright. Double it. Too big, 30. Perfect. No. Actually, let's go 35 by 35 by 35. No, not 35 by 35. No. 32. Perfect. Perfect. Union group these two. Align. Perfect. Union group. And now for the trickiest part. Over here, there's a slight dome around it, which is going to be a big pain. But I have it checked. So, 2, no, 3. I cooked myself. Why did I do that? Why didn't I just union group it? Union group. Boom. This looks very sloppy. probably because I did this in like 20 minutes. But, wait, I just realized. How am I going to do the hand? Flip you over. Land. And this one's a touch too big. So, over here, I'm going to scale it down by 2. Break apart the union group, so that way it's not implanted in. We can union group all 3, and then the whole will remain. I'm a genius! Oh my gosh, I'm a mastermind. How am I going to get the details? Okay, thankfully there's only 2 hands. No, fingers. So, we do not have to, well, do an entire hand. But, how am I going to get that? So, after further inspection, if you all can see this, right here, upon further inspection, it's actually connecting through a ball and socket joint, which, by the way, I've never once made in my life. And there's also another joint. Oh, just great. But, this guy is very helpful, but, he already made my idea, so we're practically just learning from him and making our own. But anyways, so as we can see, we have another one of these type of joints, right? And then we have a ball and socket. So, scooch this over to here. We're gonna, yeah, use a ball and socket. Alright, so you're wondering why are we using a ball and socket joint? Because your hand has 2 movements. This way, as you can see, that'd be 1 hinge. Then over here, can bend, like that, which is another hinge. Which that means we need 2 hinges to mimic a hand's movement. But then with 2 hinges, then we could also move this way, which your hand cannot. So, and also a ball and socket joint can actually rotate because your wrist rotates through here, but in the game, in reality, this doesn't rotate from a robot arm. It actually just rotates your hand, of which this would also work for rotation and stuff. And yeah, also ball and socket joints are way more efficient and price efficient, so I'm going to also choose that for that reason. And also not take me another 3 years in order to make it. So yeah, this is also my first ball and socket joint. So yeah, I'm learning. And yeah, that's our test print over there. Continue the video to figure out why it's our test print. And why instead of, that. So that one this will just be for display instead of actual functionality. So we don't have to do the painful carving out thing again and just make it all nice and tiny. 5 by 5. Nope. 10. Yeah, 10. 10 fits it. 10, 10. Alright. Make it like 9. And then we want it in the upper quadrant. So, of which, you do a beautiful thing known as adjusting your snap grid. Like that. And beautifully, we've made it beautiful. We union group this, and this one will just be for, looks. But, anyways. Sorry guys, something happened there, but, back to making the ball and socket joint. Over here, we can see it protrudes out just for a second. So let's see. Let's just use a cube for this one since it doesn't need much detail. Alright, like that. And then we just, you see, well, you know, at the ball and socket part. So let's actually make this its surface area. And then let's scale it down to a 10 by 10 by 10. And yeah, that should be it. And of which now, we actually have to make the hand after this gets fused. How do we fuse it, you might ask? Pretty simple. You put something in between it. For example, I'm using a cylinder. Switch it to the side, and then just like that. The ball should fuse once we print it, but it's going in just one, so that way we can assure that it is fused. And I'm going to union group this, so that way, in case, you know, I need to move it, you can just grab the entire thing. Let's hop to the difficult part, the hand. Let's see how this will be made. Break that apart. Give me a second one of the balls. Yep. Alright. So right here, it's not actually talking about ergonomics, so pause it for a second so that way we can explain. Alright, after my nice explanation that I probably had. So, what we're going to do is we're going to get like a box or something. Drop you to the floor. We're actually going to make this a 10 by 10 by 5. Stretch this out to a 13. Pull this up. Now, with our beautiful, once I showed you all my beautiful explanation, we're going to grab this, increase its size, and then we're going to align them, you know, smack that metal, and just like that, we have a semi-perfect thing. As you can see, it will, well, reach everywhere the same way, but with the hand, as I reminded you, it can go in one way a bit further. So, I'm going to union group these, that we're going to save the ball. Control CV the ball. Union group these, and as you can see, it will now be like a ball and socket joint, where it can move up and down freely, but left to right will be a bit tighter. But to ensure that everything works out the same, I'm instead just going to, well, block off the side. 2, shrink it down, a bit more. There, beautiful. Then we're going to scale this to there, and just like that, it should be set. But there's only one way to know this, and it's by printing a test part. So of which we're going to remove this back, union group it, and dismantle. Union group. We're going to export this as an STL, then export this as an STL. And we're going to, well, collapse this down. Go to our beautiful Bamboo Studio. Boot it up. And, let's see how long it'll take to print, and, wow, it's taking a second. Can you just, thank you. Thank you so much. Anyways, create a new project, import. Want to select these two. Open them. Yes, multiple parts. And here they are. And I think we need to scale this all up in the end. But, for now, scale to 200 times the original size. I'm gonna set support. Disable it. No, wait. For you, and only you, will enable support. Never mind. Okay, wait. I messed up importing them one at a time. I just, well, did it. And then scale 200. Enter. You there. Scale 200. Bam. And you will have support. But you know support. So, slice the plate. Should be done in 26 minutes. And I'll use a bunch of filament. But this is for science. For science. I'm gonna print the plate in black. And, I'll get you all back for once and when I'm done. Any second now, and bye. As you can see, it'll just layer it up. Bye. Alright. First test has been printed. Do they fit? And, let's see. I'll put it up closer to you guys. So, if we put it here, it's too loose. And, right here, it didn't prevent it. As you can see. So, two things we need to fix. So, this right here, the length of this, and then the, size of the ball we made here. Because that was too big. So, yeah. We need to fix those two things until a test print might work. But right here, we also need to block off something or do something. So, first test print, fail. Alright, we're back in the editing software and we saw what was wrong. So over here, this didn't block off enough, and the ball we used to size it, to hollow out the carving, was too big. So we need to ununion group all of it. We also only need one ball, so... No, we want this. Just bring it down like that. And then scale. So if the real size is 10, how about we don't use 11? We use 10 point, hear me out, 2, 5. Enter. And rescale it all into 10.5. Like that. And this would make a tighter fit, and a sort. So yeah, this is all we're going to do for our next test print. Just print this part. First we gotta union group it, and then we can export. STL. Back to Bamboo Studio. Prepare. Delete that. Delete that. Import new item. Number 2. Let's try this. Scale. Upwards of 200%. Now hopefully this will work. Let's see. The only way to know is to print it. Print. And black. Send. Alright, I'll get back to you all once it's done printing. I also gotta eat lunch. So see you all later. Alright. Test 2 has completed. Here they are, and, still not tight enough. That means we have to go tighter. And, yeah. So here they are. If we combine them, they separate too easy. And, we have to... So at first it was too big, and that was too short. So it didn't stop it, but now this is just barely too short, and that is also not tight enough. So, which means, please let our third one be the correct size. And finally, our third attempt. So this one was a fail. This one was the fail. And here's our final version, I think. And it's also a fail. I swear, what? Wait. I think I realized something. Let's see. We turn it this way, it actually will lock into place. As you can see. But that's because of this bump. Right here. That protrudes outwards. And then, as so, it stick better in. Which leaves one idea. We make the hole, or the gap, smaller than the ball. Might work, might not. It's our only option now. Because I'm brain dead of why won't any of our 3 attempts work. If none of them work, I'll turn to the less efficient hinge method. Alright, let's print it. Alright. 4th attempt complete. It's actually smaller than the ball itself. Does it work? I mean, like... It's pretty tight, but, it isn't fitting. But I think I figured this out. Okay, so see right here? Here's how much surface area we're grabbing, right? That's how much surface area. This is how much surface area the ball has. Combine these two together, and look at that. Look at how little surface area it needs. And then I want to pause this so that way I can go get a Lego piece and show you. And here's a Lego piece to show you how much surface area there is. So we have this red one, and then we have this gray one. Once when we stick them together, they stay together. Look at this. You can bend all the way around, and it doesn't come out. So upon further look, you can see right here, we can have a lot of grip on it. Look at that. Covers the entire ball. See? Except for this top part. Of which I think this is how we're going to make my ball and socket joint. I'm going to skip to that version. So that way you don't have to watch me do a bunch more. Alright? Alright. Let's do this and see you later. Alright. Final version that I'm going to try until I have to go somewhere. Alright. Here it is. And look at that. It holds. Although I do have to fix this part over here. But yeah, it works. I think that's all that matters. So now I can continue the model. And it doesn't even bend this way. It's nice. I'm so sorry guys, but something happened and I cannot find my video recording. But I will show you the final project over here. Here it is in all its glory. We scaled it up so that way we could actually like mess with it. And it's currently printing right now. We have the hand, we have the fingers, we have details, and we have both the arm parts. So yeah, I'll get to you all once when the arm is done printing, and bye. It is in the morning, and I finished assembling it, and here it is. It's a movable joint that you can take off. So that way you're just left with the forearm. Here's the biggest part of it all. It's not really that big. And here's the hand. Right here. This one came off. This one's loose. This one's bent. Yeah, the connections were not very stable, but what matters is you can bend them. Just like that. Do however you want. Except for this joint, because this one I had to glue back. Let's see. And also it restricts movement towards the thumb, like in an actual hand. And then it moves that way with ease. Like this one. And it bends this way. And this way. So yeah, it perfectly mimics the arm. It looks similar to how it would look in the game. It even has holes and designs where the heck the joint would be. So, I say that it's complete. A side effect from this design, right here, this circle, is that they connect perfectly. But, so yeah, guys. Here is the arm, and I hope you all like it. Time to figure out what next I should make. Bye.